So today what we're going to be looking at is numbers in the complex plane, mainly what we call our I tables. Now our I tables, what we've got here is I've got I up to the 20th power. We're going to know something very special about that. Remember, if we know that I is equivalent to the square root of -1, what we know is that when I multiply I times I, I'm going to get the square root of -1 times the square root of -1. Or when I put those two together, that is the square root of -1 times -1, which is the square root of -1 squared, or -1. So I'm going to get a -1 value in there. I itself is just going to be I. So I have -1, and if I multiply that times another I, I'm just going to get a negative I. And I to the 4th is I squared squared, so what is -1 times -1? I'm going to get a +1. So far, so good? Well, if I keep adding the square root of -1 multiplied times itself again and again, here I have I to the 5th. Well, I know I to the 4th is 1. I know I to the 1st is I, so 1 times I is I. I to the 6th can be broken down into I to the 4th, which is 1, and I squared, which is -1. So in essence, I have 1 times -1, which is -1. I to the 7th, again, it's just I to the 4th, which is 1, times I to the 3rd, which is -I. So 1 times -I is going to be -I. And I to the 8th is just I to the 4th times I to the 4th, which is 1 times 1, which is 1. And then at this point, we should notice that there's a pattern going on here. Our I tables repeat. I have I, -1, -I, +1. I, -1, -I, +1. Or if you want to look at it as every other, have I, -I, I, or I could say -1, +1, -1, +1. Cool. We've got a pattern here. Every 4th I value creates a pattern. So I know the number that comes after +1 is I again. Then I know it's going to be a -1. Then I know it's going to be a -I. Then I know it's going to be a +1. In which case I repeat the pattern. I, -1, -I, +1. I, -1, -I, +1. Boom. And so our I tables are going to really help in understanding what happens when we start multiplying by numbers. So down here, basically all we have is we have no more than, I think, I to the squared. But let's go ahead and take a deeper look. So when I distribute an I amongst anything, I'm going to distribute it just like I would a normal number. I would say I times 5 is going to be 5I. The big thing that happens here is when I multiply it, I'm going to get plus 4I squared. And as we've just discussed, what is I squared? -1. So it's actually 5I plus 4 times -1. So 5I minus 4. And then the last thing that we need to pay attention to is lateral numbers or complex numbers are always listed in what we call A plus BI format. We always list the real part first and then the lateral. So I'm going to say, okay, my real one is -4. My lateral one is 5. So I'm going to say -4 plus 5I. There we go. So for number 3, I'm going to do the exact same process. I'm going to distribute my 5I to both these terms. And I'm going to get a 50I minus 60I squared. I know I squared is -1. So I'm going to get 50I minus 60 times -1, which is just 50I plus 60. And then I'm going to write it in the A plus BI format, which means I'm going to list this number first, 60, and my 50i second. And that's it. That's really all that's involved with multiplying i's, even if it's as complex as binomials. If I have this, I'm just going to distribute each term. 2 times 3 is going to give me a 6. 2 times I is going to give me a 2i. I times 3 is going to give me a 3i. I times I is going to give me an I squared. Now the cool part is when I multiply two complex numbers together, because this is really one complex number, I'm going to end up with one complex number. My i's combine, I get 5i. This is going to turn into a -1. So I'm going to end up with a 6 plus a -1, which is just going to be a 5. So I have a 5 plus 5i as my answer. Awesome. And so what I want you to try and do is I want you to try number 7 on your own. Pause the video, knock out number 7, resume it when you're done, and see how you did. Okay, so what you might have noticed is that number 7 is a little different. Same process, but something cool happens. I multiply this positive number times this positive number, or this complex number times this complex number, and I get a 100 minus 10i. And then when I multiply this, I get a plus 10i minus I squared. I notice my two complex numbers cancel out. My two lateral aspects go away. And what I'm left with is I know that this I squared, that's 100 minus -1. That actually turns into 100 plus 1, which is 101. And there's a cool mechanic behind that, and it has to do with how we actually multiply number lines and the visual mechanic of what's going on. What we have right here is that if I were to, let's say, multiply a number like 2 times 3, they're both in a singular direction on the number line, with 0 being over there. I would say, okay, I'm going to go 2 groups of 3. So 3, 3, and I'd end up at 6, because they're both heading in the same direction. Now, with my complex numbers, basically what we're doing is we're going off the number line. If I have my real axis and I have my lateral axis, I know if I go 10 plus I, there's my first number, 10 minus I, there's my second number, I'm going to end up multiplying my two real aspects, 10 times 10, I'm going to get 100, and my two basically lateral aspects are going to cancel each other out. Part of it's going up, part of it's going down. They're going to completely do away with each other. And I'm going to end up back on the real axis. So we'll get more to that in a future lesson, but just to show you that when we multiply complex numbers, we're really dealing with more of a vector system. But let's move forward. Let's try this one again. For this one, when I distribute, I get a 12 minus 6i. When I distribute my lateral aspect, I get a 24i minus 12i squared. Then two things happen. I combine my lateral aspects and I get plus 18i. And for these, I'm going to get 12. That's 12 times -1. That's going to be a plus 12, which is going to be a 24. My 18i is just going to hang out, not causing any sort of a ruckus right there. And so over here, we notice it's the same pattern. I have a 2 plus some complex aspect, 2 minus some complex aspect. So I bet you I'm going to end up back on the real axis. I get 4 minus 10i plus 10i minus 25i squared. My complex numbers cancel out. My I squared changes that. So that turns into minus 25 times -1. So that is just 4 plus 25, which gives me a 28. 9. And so again, kind of what we're seeing here is we're seeing another aspect of what's going on. My 2 plus 5i in this case is 2, 1, 2, and then I go up 1, 2, 3, 4, 5, and then I go 2, 1, 2, 3, 4, 5. I notice that the real number trajectory, 2 by 2, is going to give me a 4. And then I notice that the lateral trajectory, because they cancel each other out, rotates itself. And I get that result right here and I end up at 29. But again, we'll get more into these mechanics at a later date. But there we go.